Our next guest is the Chief Security Architect from Tanium, Mr. Ryan Kazanciyan, right? Ryan, come up on the stage. Welcome.
Thank you.
Good to see you.
Good to see you. Appreciate it. Thank you. Good afternoon, everybody. Thank you for your time today. So I'm here to present the 7 habits of highly effective hackers and really share with you some of the experiences that I've had working with organizations dealing with targeted threats over the last 10 years, and some of the model behaviors that we can learn from the most successful attackers and apply to ourselves to better secure our own environments. Unfortunately, because we're a bit short on time, I'm actually going to focus on 5 of the 7 habits. We'll have to leave the other 2 for another day. But to give you a quick introduction on who I am, I live in Alexandria, Virginia, right outside the Washington, D.C. area, although my employer, Tanium, is based out of the West Coast in Emeryville, right outside San Francisco. I've been with Tanium for 2 years. I oversee our strategy for what we build in the endpoint security detection and response space. Prior to that, I spent 5 years at PricewaterhouseCoopers focusing on offensive security, vulnerability assessment, and penetration testing, and then 6 years at Mandiant as a technical director in their IR practice, where I focused on investigating and responded to targeted attacks. I'm co-author of a book, Incident Response and Computer Forensics, which came out in 2014. And I also work as a technical advisor for the TV show Mr. Robot. I worked on the second half of Season 2, and I'm currently working on Season 3. So with that, let's start about the first lesson, which is knowing your environment. If you've ever responded to a targeted attack by a so-called APT-type attacker, you'll find that the first stages of an intrusion after the initial infection are actually kind of boring to watch. Attackers will spend days, sometimes even weeks, collecting the most mundane information about an environment. And the way I like to analogize it is, imagine you've been thrown into a new job in IT or security, and you're given a computer and absolutely no more information about your job. So you have to figure out the lay of the land. You have to identify users, you have to identify systems, and you have to identify data. And for an attacker with a specific mission objective, the goal is to do so in as low footprint of a manner as possible, to, as passively as possible, survey the environment and get themselves to their target. Most recently, there was a great article today about Alexei Baland, one of the hackers indicted for the Yahoo breach, and it talks about one of his methods being using things like a bit of network scanning, corporate wikis, intranet sites to harvest data and information about an environment. So this is critical information for an attacker. Now, the interesting thing is, if you look at the peers in our security industry, and if you look at most security teams, their understanding of the assets and inventory in their environment is often very poor. This is usually the domain of IT, not security, and even IT often relies on really stale, out-of-date information. At Tanium, the organizations we work with often find that they don't know about 12 to 20% of the assets in their own environment. And so the fundamental premise of you can't secure what you don't know about applies very strongly here. And I've actually worked cases where the security team has asked for data that was recovered from the attacker because it provided them with more insight about their environment than they actually had. And that's really backwards. A reason that I think this is really important is well displayed by a graph here that's called the Incident Response Hierarchy of Needs. And this was by Matt Swan at Microsoft. And the foundation of this hierarchy of needs begins with inventory. Because if you don't have an ability to comprehensively monitor and control your environment and understand that surface, then you can't collect good telemetry, you can't do detection, you can't triage, everything else falls apart. So this is why this is so fundamental. And one of the keys to good inventory isn't just to create a static list of systems and groups. If you look at a change management database in most organizations, it's usually fairly stale, one-dimensional data, where every user or system is put into a static list or a static grouping that is very simplistic. But this isn't really how attackers look at environments. Attackers look at environments as this sort of dynamic graph of interconnected resources, where every attribute about a system defines its attack surface. Things like who's logged onto the system, who recently authenticated to the host, what types of applications are running on it, and what is their patch status, what functional role does the system have in the environment, and what is it interconnected to. And organizations who can dynamically track these attributes on a constant real-time basis can do a far better job of securing those assets. And this leads us to the next point, which is assessing vulnerability and risk. By necessity, attackers that are operating in an unfamiliar environment need to be brutally efficient. They need to take the cheapest path possible to achieve their objective without getting detected. Unfortunately, the corollary to this is that we are not very good at assessing risk and often prioritize the wrong things. So from the attacker's perspective, let's say I've breached in an opportunistic manner some systems in the help desk group in an environment, and let's say my goal in this victim is to go to the point of sale terminals. As an attacker, I want to find the most efficient route through the environment that will lead me from an opportunistic foothold to my actual mission objective. And this is best likened to traversing a graph. John Lambert at Microsoft has a really good way of putting this, that hacking is basically graph traversal. And this diagram you see on the lower right-hand corner is actually output of a tool that some friends of mine in the industry have written called Bloodhound. And what Bloodhound will actually do is run through your environment and take your Active Directory and build a directed graph of privileges that allows you to find routes to privilege escalation from different vantage points in the environment. And this is exactly how attackers operate when they move laterally and steal credentials. They want to find that efficient route. This is the way you have to look at your environments to really understand how it could be breached and how an attacker could take advantage of those relationships. Unfortunately, again, a lot of people don't see security this way. So the Ponemon Institute does a survey every year of the state of the endpoint. And one of the questions they ask respondents is, what are the top threats that you're worried about in IT security in your environment? The top response for the last few years has been threats from mobile devices. So as you see here, 86% of respondents said the greatest threat that they saw came from mobile devices such as smartphones. Risk from existing systems in their environment, like laptops and PCs, was only 35%. This is a massively overstated risk. Verizon every year in their data breach report, the DBIR, tracks the percentage of malware-borne threats on mobile devices. And actually, they stopped doing this in 2016 because it was so insignificant. But in 2015, the last year where they were tracking this, they found that only 0.03% of mobile devices were actually infected with malware that was considered truly malicious, and otherwise not just delivering advertising or malvertising. Now, 0.03 of billions of devices is still a lot of devices, but I can say that in the dozens and dozens of targeted breaches I've worked, and the many more that you've read about in the news, not a single one of them was born from a mobile-originated threat. Because from an attacker's perspective, it simply doesn't make sense to invest the effort on compromising a single user's phone when you can just breach a system connected to the corporate network and have that entire set of resources available to you with a couple of hops. And this is more so exacerbated by the fact that if you set aside Android, the mobile threat space for iOS is basically non-existent. This is why a zero-day exploit in iOS will net you about $1.5 million. They're unicorns. They exist, but they're not going to be used to compromise your enterprise, full stop. The other thing that gets overstated a lot is the risk and impact of zero-day threats. And in the same survey, 71% of respondents said that zero-day threats were what they felt would induce the most harm in their environment. And again, this drastically overstates the prevalence and impact of zero-day threats versus other types of malware and infections. So, to wit, Microsoft in Black Hat last year talked about how difficult it's actually become to craft zero-day exploits. And if they contrast what used to be very simple about a decade ago, now the combination of mitigation techniques and security controls that are baked into operating systems has turned exploitation into a very complex multi-step process, not just a singular quick and easy event. You often have to chain together lots of really complex exploits to make something workable. And that makes it more expensive for attackers. Brilliant researcher Halvar Flake commented about how time to exploit has gone from days to weeks or months when vulnerabilities are identified. So what are people being compromised by? Stuff like this. So this is an example of macro malware delivered through Microsoft Office. And this technique has existed for well over a decade, yet it is incredibly prevalent. In fact, even more popular now than it was a few years ago, because it's application layer and it works. So this is a great example of the social engineering aspect of this attack. It says the document is encrypted, please click enable editing. Obviously, if you actually follow that instruction, you're allowing Word to run the macro and infect your system. Same idea here. There is a clever error message that says some parts of this document cannot be displayed. Click Enable Editing and Enable Content to display them. And of course, this will run the malware. So very simple technique. Last year, in the first half of 2016, Microsoft's online services reported that 38.5% of the malware that they saw in their hosted services came in the form of Microsoft Office documents. That is an enormous percentage of threats. This quote, I think, really summarizes the point here, which is that we get so spun up on the sexy and glamorous types of exploits that we often disregard the mundane things that really matter. And the analogy I like here is that if security were an NBA defense, it would spend 100% of its time practicing on stopping half-court shots and 0% of its time on everything else. And a lot of us are guilty of that in industry. All right, let's move on now to talking about learning from attackers and how they build on platforms. If you look at some of the most successful and well-designed malware frameworks, backdoor frameworks, botnets that have existed over the last 5 years for both targeted and opportunistic attackers, you'll find that they share one thing in common, which is a modular, platform-centric design. And what I mean by that is there'll be a core portion of the malware that is then complemented with payloads that are delivered in separate modules that provide different functionality. So let's take Cozy Car as an example. Cozy Car is used by APT28, infamous for the DNC hacks. And Cozy Car has a very well-written core and then can take modules that are actually delivered in memory from the command and control server on demand that provide features like credential gathering, screen scraping, keystroke logging, and so forth. Very elegant design. Other botnets like Zero Access that are designed to deliver a very large variety of payloads follow kind of similar models. For an attacker, the obvious benefits of this are extensibility and flexibility. You write a good framework, and then it's easy to build features on top of it. Operator consistency is another thing. If you think of a targeted group of well-funded threat actors working as a team, you need to make sure that your operators who have hands on keyboard are doing the right things. And the more you can structure their operating environment, the fewer errors they make, which means the less chances they have of getting detected. And as an attacker, you run a better team that way. There are development efficiencies in being able to modularize your code and your tools so that you can have multiple work streams as you develop your malware platform and its capabilities. And you can also better control your endpoint footprint to help manage how your malware might be detected or how the resources it might use on a system are controlled. So these are all things that are actually good principles for software design in general, as well as for looking at how we can manage our own endpoint security and endpoint management software. Now, if you look at what we do in industry, the Ponemon survey of state of the endpoint last year reported that 34% of respondents have 6 to 10 security and management endpoint agents running on their environment. 6 to 10. 15% of respondents said they had 10 or more. 6% of respondents actually said they have no idea how many endpoint agents they have, which I can only take to mean that they gave up counting after 10. But this means that there are 6 to 10 or 10 plus management consoles. 6 to 10 or 10 plus endpoint executables running continuously, chewing up resources. 6 to 10 vendors to deal with, training sessions. The overhead of this is non-trivial. And what this might mean for a user is that when you open up your taskbar, you see hopefully something not quite this bad, but just this overwhelming number of things running in the background. But what this also leads to is this vision of a SOC, and everyone has seen the Security Operations Center of the future where you've got this massive mission control with dozens of consoles, and everyone loves showing this off. But to me, this shows massive inefficiency. Because if your team needs to look at 30 different screens from 30 different products to figure out the security state of your environment, they're never going to get anything done. And as Silicon Valley, the TV show, captured this well, all you end up doing is really reducing productivity and playing Minesweeper across, or Solitaire across 6 monitors. This is not efficient. It's also actually not secure. So Jessica Payne at Microsoft has a great quote here where she talks about sometimes the best way to enhance security and to reduce the attack surface in your environment is not adding more technology. It's consolidating and rationalizing and taking away technology. And I've seen this firsthand in industry. One of the most important drivers, I think, that a lot of organizations are looking towards now is how they can consolidate their endpoint footprint and manage and secure their systems without this agent sprawl. It's really critical. This leads us to talk about living off the land. And this lesson and this habit is more for the security vendors out there rather than the corporations that are buying security tools. If you're an attacker writing malware, like the backdoors I talked about earlier, one of the decisions you have to make is where your malware is going to run. Is it going to be resident in user land, or is it going to be in the kernel? And traditionally, people have always thought of advanced malware as employing rootkit-like techniques that require some level of kernel footprint, meaning if you want to hide and interact with the system at the lowest level possible, you run in ring 0, or you at least run part of your capability set in ring 0. But there's a real trade-off to that and a challenge, which is that it is more difficult to write code that can reliably run in ring 0. In some cases, that can increase your likelihood of detection. And as operating systems have done a better and better job of trying to control what runs in ring 0, it's become more difficult to engineer around that. A lot of times today, you'll see kernel rootkits actually have to rely on exploiting some other legitimately loaded driver as part of their loading mechanism to get untrusted code learning in the kernel and bypassing OS security mechanisms. And so what I've seen over time, and firsthand through anecdotal experience, this has been very true, is that attackers actually run in the kernel less and less often. Because the fact of the matter is you can run in user land and achieve all of the objectives from a functional perspective as well as from a hiding perspective just as effectively. And you end up with more reliable code that's not going to blue screen boxes, that is easily portable between versions of operating systems, and that is just flat out better for an attacker. A good design principle for software in general is don't run in ring 0 unless you absolutely 100% need to. And if you look, for example, at the zero access botnet, which in its peak, I think, had millions of infected systems. The most recent generation of the zero access botnet actually dumped all of its kernel-level components for pure user land operation because of this exact reason. So unfortunately, in the security industry, we're often guilty of making this mistake, and a lot of companies out there, especially in the antivirus industry, have run code that isn't terribly well designed or secure at a lower level than it really needs to. And Google's Project Zero, especially Tavis Ormandy, have been really prolific in identifying some of these vulnerabilities over the last few years. I have an example here where Tavis is talking about a kernel memory corruption in Symantec, where Symantec was unpacking malware using a chunk of code that was actually running in kernel space. And if you've ever worked with unpacking code, it's actually really complex code. It's processing untrusted input, and it's probably not something that you want to run in the kernel, as this comic that he tweeted kind of glibly points out. It's not the brightest thing to do. Now, I don't point this out to just call out Symantec, because similar types of vulnerabilities have been found across a very large number of antivirus vendors, and that's part of what Tavis has really done a great job of shedding light on. But it really does emphasize this principle of trying to minimize the surface of dangerous exploitable code that you author. Again, quoting from Halvar here, the solution to this is not just auditing our security tool code better. It's removing wholesale portions of code that are running in a more privileged manner than they need to, and refactoring or replacing it with more secure, more sane ways of achieving the same objective. When you minimize that privileged code space, you reduce your attack surface, and this is something that we should drive all of our security vendors to do. Now, fortunately, all of the major operating system vendors are making it easier for security vendors to write tools that use the operating system in a way that gives them low-level access to information, but does so in a sane and controlled manner. And so 2 examples of this is in Windows. There is an event tracing subsystem, which was introduced, I think, in the Windows 7 Server 28 or 2008 or 2012 era. And event tracing provides a great way to get kernel-level telemetry about what a system is doing without having to set a lot of really disruptive and potentially dangerous hooks or low-level monitoring code. In Windows 10, Microsoft introduced a feature called the anti-malware scan interface, which very few AV vendors are taking advantage of yet. But AMSI actually gives you a simple OS-supported mechanism to get visibility into things like the normalized decoded strings of script malware, like PowerShell code that's running, as well as strings of data that malware is interacting with or setting in memory. So again, a safe and sane way to collect this critical data without potentially incurring more risk and adding to the risk of a system by adding security tools that are not well written. And that leads us to our final lesson that we can learn from attackers, which is engineering for resilience. One of the statistics that is always really compelling to track year over year is the dwell time of targeted attackers. In other words, how long it takes between the onset of a successful attack and when it's actually detected. Verizon tracks this every year in the DBIR report. Mandiant also tracks this every year in their M-Trends report. They just released the 2016 edition of M-Trends, and the quote that I pulled here is the average dwell time for externally detected incidents in EMEA was 128 days last year. In the US, it was a little bit lower. In Asia, it was a good bit higher, I think something around 170 days. That is actually an improvement from prior years, but obviously still far, far too long. We can't be measuring the dwell time of breaches in months and still expect to make a dent in the impact that attackers are having. But for me, the interesting takeaway here is how are attackers achieving this? Because from an attacker's perspective, maintaining persistence in an environment for this long is actually really difficult. You have to contend with things like your backdoor software and your malware failing for unpredictable reasons, maybe a compatibility issue that gets brought up. You have to deal with your operators potentially making a mistake, antivirus potentially getting a signature for your malware and cleaning it up from a system automatically, human analysts or other analytical methods detecting your presence in an environment and kicking you out, or even something as mundane as hardware replacement. What if all of your backdoored PCs are replaced with a new wave of fresh hardware? You can lose access to environment. I look at persistence, how an attacker remains in an environment at both the micro level on individual systems and at the macro level, meaning access to an entire environment overall. And attackers achieve this by means of resilience and redundancy. So an example of this, I worked a case with an engineering and technology firm that had been breached for several years by an attacker that was stealing their intellectual property. And the attacker primarily relied on a custom backdoor framework that they had deployed to about 20 workstations and servers in kind of a random distribution across this environment. But in addition to that one custom backdoor family, during the period of compromise, they also deployed two separate singular backdoors that were completely different. One of them was a modified publicly available backdoor that they embedded in a server in a very well-disguised location and configured to beacon out to their command and control server only once a month. The other backdoor was a web-based script or web shell, and they placed it on a web server facing the internet, but they placed it there from the inside, as if they were an administrator of the web server. And they actually never accessed that backdoor at all. Those two were backup methods. So if the victim remediated and cleaned up the environment, but overlooked at least one of those secondary backdoors, the attacker would be able to regain access to their environment and continue operating. So that's one example of something I've seen time and time again, where attackers make these smart decisions to not allow single points of failure to jeopardize their entire operation. Now, let's look in contrast at what we often see in the field. Grizzly Step, again, APT28, was best known most recently for the hacks against the Democratic National Committee. But a couple of years ago, I actually worked an earlier case involved with this threat group. And it was interesting to see their approach. They spearphished a single person with a link to a malicious flash animation that exploited an end user's workstation. They got that user's credentials, and then they found a single remote access gateway that was exposing a remote desktop to the internet, and used those credentials to log in remotely like a legitimate employee, start to move laterally, and basically within about 2 or 3 days, they had a privileged Exchange account, and they were able to steal all the emails they want and achieve their mission. So in a couple of days, those single points of failure had a domino effect that brought down this entire organization. And just about every breach that you hear about in the news plays out in a similar fashion, even going to the most recent hack that has been publicized of Yahoo. And more information has been coming out about how that occurred, especially with the recent indictment. And it's the exact same story. A well-crafted spear phishing email opened up by a user. In this case, I think it was someone in an engineering or IT type role. And that led to the domino effect that ultimately exposed hundreds of millions of Yahoo accounts. We cannot continue to succeed as an industry if we allow these single points of failure to jeopardize entire environments. And the analogy I like to draw is if you look at the design of container vessels and other large ships, they're designed to not allow single breaches of the hull to flood the entire ship and sink it. And so they use compartmentalization and bulkheads so that single breaches in different locations can allow localized flooding, the ship can maintain buoyancy, and you can still operate and plan for that failure. That's really a model that we need to look towards to our security controls. I mean, yes, defense in depth is a 20-year-old concept, but we're not doing it right because we're focusing on all of the distractions like zero-day vulnerabilities and trying to find the silver bullet next-gen anti-malware solution instead of actually thinking about fundamentally managing and securing our assets in the first place. And so following this approach of resiliency, as attackers do in their own breaches, can really help us a lot. So I wanted to close with a quote, and originally I was looking for quotes about learning from your enemy, learning from your opponents, and I kept finding quotes by Sun Tzu. And I really didn't want to use a Sun Tzu quote because if you've seen any presentation on industry, people quote Sun Tzu in The Art of War all the time. It's way, way overused. It's a little trite. So I did find a good quote that was ascribed to Nelson Mandela. I'm not sure if he actually said it, but the quote was, "I never lose. I either win or I learn." And I think that's really a good model for what we can do from our attackers. See the attackers' methods, understand why they're being successful and how the best equipped and best functional attackers manage to have successes, and learn from that, just as we can learn from other teams. See where they have their successes and model our defenses and how we manage our technology, our people, and our processes to have the same sorts of successes in defending against them. Thank you for your time. We have 3 minutes, so if there are any questions, I'm happy to take them at this time.
I've got one for you.
Sure.
What's the question you get asked most when, as I guess you're an advisor for the robot, right?
Yes.
All right, so what do they ask you the most, especially if you're going into the 3rd season, is that right?
Yes.
So what do they ask you the most?
Well, setting aside questions about the show and what's going to happen, the one I always get the most is, do you cover up your webcam with tape or something?
And do you?
I do, out of simple paranoia, but if I'm not using the webcam, we got one of those like sliding things to
I do the
cover it
same
up.
thing.
Yeah, it doesn't hurt. Simple security control, but every little bit helps.
Who here, raise your hand, who covers up their camera on, wow, see?
Now, of course, that doesn't protect the contents of your screen from being recorded or your microphone or a million other things about what you're doing on the system. But again, you know, security comes from incremental good steps. You're not going to have one thing solve all your problems. So every little bit helps.
Which part of the world is, I guess, is better armed or is most secured against, you know, hackers or cyber attacks?
So I think there are definitely regions that have started trying to chase down or improve their maturity faster than others. So while I don't think any region can say that they are hack-proof, like you will see large breaches affecting the global Fortune 1000 at every region, but I do think that if you look at government and finance in the US, as well as technology, like the top 10 technology companies, they certainly have been more forward-leaning in how they apply technology to tackle a lot of these problems because over the last decades, they've dealt with it all firsthand. In contrast, I think where you see a lot of room for development and opportunity is in Asia, especially in Japan. A lot of companies are taking a much more serious look towards information security now, but are still lagging a couple of years behind their peers in Europe, and then likewise even a few more years behind their peers in the US.
So, all right, but you would say North America is still ahead of Europe?
I would say so, but I think the gap is shrinking very quickly.
Okay,
absolutely.
Very good. All right, Ryan, thank you very much.
Thank you.
We appreciate it.
Appreciate
We'll be watching the robot too.
Thank you.
Thank you.